So now we're going to look at finding an inverse from a graph. We're going to be graphing that inverse. So, and an interesting thing will happen. Let me scoot this up a little bit. Okay, so here you see a quadratic function, but it's restricted, right? From 0 to infinity, okay? Now, when we want to do the inverse, let's first look at some points on f of x. So let's just look at, some of the points that we have. We have a point at 0, 0. We have a point at 1, 1. And we have a point up here at 2, 4. And that's true. So you could identify those points off the graph. We know it's a quadratic function because they tell us that. Now, if we look at the inverse, we're going to switch those inputs, outputs, the x and y. So we're still going to have 0, 0, because if you switch 0, 0, it's 0, 0 still, right? We're still going to have 1, 1. And we're still going to have, or we're going to have a different point, 4, 2. Now what happens when we graph those points? Well, we have 0, 0 here, 1, 1 here, and then we have 4, 2. So it's like out here. Okay, now that graph is going to look like this. Okay. If you think about the quadratic function, so f of x being x squared, and we've said x is greater than or equal to 0. And then you think about, well, what's the inverse of squaring something? You could say, well, if I want to do the inverse, that would be y equals x squared, or x equals y squared, or the square root of x plus or minus equals y. Now, I'm spending a little bit of time on this, but that's how you would solve it. The problem comes in the restriction because we needed it to be 1 to 1. Remember, we said x had to be greater than or equal to 0. Then that means in the inverse, y has to be greater than or equal to 0. Think about switching out the x and y, okay? That switch. Okay, then we get if y has to be positive, then we don't get the plus or minus here. We're just going to have the positive case. So we get the square root of x equals y based on the restriction that we had from the original function. And so f inverse of x equals the square root of x. And we do know the restriction on that. X has to be greater than or equal to 0 because it's a square root function. So that might all make some sense to you algebraically. If not, though, look at the picture and what's happening. So you see this, it's blue, but you see this curve for the squaring function, and then we have the inverse function going like that. So an interesting thing happens. If I were to draw the identity function, the line, it should go through there. Okay. See that line there? That is the y equals x line. If I were to fold my graph paper there along that green line, the points from the original function would line up with the points on the inverse. That is true about a function and its inverse. They have to be symmetric. Let's see. So a function and its inverse must be symmetric about the oops, that doesn't say y. Y equals x line. Okay, so you could fold along that green line and the points would line up from the two graphs. So if you remember that, it's a good test if you have a graph to see if it's an inverse. You can think about it being symmetric. about the y equals x line.